Good morning, everyone. Welcome to a Monday morning of Chem 1211 with your host, me, Dr. White. Now, there's been some major changes because I had to make changes per department rules that got changed or clarified is a better way of putting it. So I wrote a new syllabus, and this week, instead of last week, which I should have given test 1, I will be giving quizzes 1 and 2. Essentially what I did is take test 1, cut it up in half to make quiz 1 and 2. Now, let's go through some important stuff. And I just realized I don't have Blackboard open. So let me open it. And now let me show you. All right, thumbs up, people. Everybody see Blackboard. Quiz 1, thank you. All right. Now, because it changed on Tuesday of this week, I will be giving quiz 1 online. At that time, I'll be emailing you a password for the quiz 1 PDF file. You'll have until 11 o'clock Wednesday morning to upload quiz number 1 as a single PDF file. I have instructions, just like you've been doing labs. Now let me go to student view. And if you see, this is how you would see it. If you click on assignments, you'll now see quiz number 1. And notice it's a PDF file. When you click on that, you'll be asked to give a password to open it up. And I also have here the periodic table you should be using. And what you'll do, enter the password. You can either print it out and write your answers on your printed paper and then turn it into a PDF file by your scanner or with your cell phone, and then upload it to the assignment area here. Let me exit. Here I have instructions. Most of you have figured it out by now, the same way you're doing labs, make a single PDF file. Now, on Thursday morning at 8 a.m., by the way, we'll still have our Thursday Zoom meeting for the lab on Tuesday. And you'll have essentially more than 24 hours to find a window to take quiz number 1 and upload it by Wednesday morning. On Thursday morning at 8 a.m., even though we don't have class or Zoom meetings, I will send out the password for quiz number 2. And you'll have until 11 o'clock Friday morning to finish, and that should be quiz 2, not 1. Sorry about that. Let me edit it. Now, when I submit it, you'll get another email. Sorry about that. All right, on Friday morning, you'll be Thursday morning, I'll send out the email with the password for quiz 2. Sometime Wednesday afternoon, you'll be able to download quiz 2 from the assignment area, just like you can quiz 1. Now, it's not visible yet. And you'll have until Friday morning to take quiz 2 and upload it to the assignment area, Blackboard, is a single PDF file. Now, I reserve the right to subtract up to 25 points. Yes, 25 points for anyone who does not follow instructions. That means you should upload it as a single PDF file, and you should upload it by the deadline, please. Now, quiz 1 has 3 pages. I didn't include important information because there was nothing on that quiz or in that quiz that you need important information. All right, it has 9 problems. 2 of them are multiple choice. The rest are some are multiple part, and it's worth 50 points, 50. It covers chapter 1 and 2, along with the number of protons and electrons from the periodic table, along with the names and chemical symbols of the elements from the periodic table. And here you'll need the periodic table, which you can download from the assignment area. Now, quiz 2, which will be given on Thursday, and you'll have until Friday to upload it, has 18 problems, including 6 multiple choice. It's worth also 50 points. My tests are 100 points, and it covers chapters 3 and 4, along with temperature conversions. The same important information for test number 1 will be for quiz number 2 you'll be given, which is the temperature conversions. And I recommend that you download the PDF file as soon as it's available. That way you won't have any problems. And once you get the email from me, then you can start quiz number 2. Now, normally I only give 1 quiz a week, but because I had to do the sudden change and give you quizzes instead of tests the way I had it planned, we're having 2 this week. Because of my schedule, I will have quiz 1 and 2 scores by this Sunday, 1 p.m. or earlier, posted on Blackboard. I will also post an announcement and send out an email when I've done that. I also, by Sunday, 1 p.m., for each quiz, I will send you an email with the individual points you receive for that, every answer on that quiz. I can't hand it back. Can anybody reach through the screen? Uh-oh, it's awful humor Monday. Here's your quiz. No, you can't. And this is how I've done it all throughout the pandemic. Now, on a week from today, Monday, I will go through in the Zoom meeting both quizzes, the answers for both quizzes, but I will delete that from the video. Again, I'll go through the answers for both quizzes, every question, because if I make a mistake on grading, and you'll know by how many points you got from the emails I send you, please let me know so I'll correct it. Students should never be penalized for a mistake I make on grading a test. Now, if you can't make Monday's Zoom meeting, and because I'm cutting out the answers, come to any of my office hours. You can't come to an office hour, email me and I'll see if I can set up something special if you need help determining answers. All right, that's quizzes for this week. Now, because of the change, I've changed my syllabus, and let's look at that. All right, thumbs up, people. Do you see my syllabus on your screen? Thank you, Brianna. All right, now, everything is the same, but here are the changes I had to make. All right, first of all, instead of the test I had, we're going to have 6 quizzes. Now, unlike tests, Quizzes, I'm not sure within a day or two when I finish certain chapters that will be covered on a quiz, which is why quizzes 3, 4, 5, 6 are not, I don't have a date there. I will tell you a couple days in advance of the week will go when I'm giving a quiz. Now, tests 1 and 2, quiz 1 and 2, I've already got the dates. After quiz 2, I will give test number 1, and the date hasn't changed for that. Test number 1, you have to take at Glen Ellen Testing Center. Same thing with test number 2. Both of these dates are the same as my previous syllabus. You need to take these tests at the Glen Ellen Testing Center. You should bring your own calculator and you'll need an ID. They're open Monday through Thursday and also Friday. They're and Saturday. I better take some tea. They're not open Friday. And so this is one of the big changes. Instead of 5 tests, there's 6 quizzes and 2 tests plus the final. Now, the final will still be given during the week of finals week I had in my previous syllabus, but you'll have, and just like the previous one, you'll have from Monday until Wednesday, 11 a.m. That's when I'm going to pick up the Scantrons to finish the final exam. It's a 50-minute final exam that's timed. If you're a special needs student, you get twice that. Speaking about special needs students, all special needs students, you need to bring in a either printed copy or a screen capture that'll be on your cell phone of your letter from the Center of Access and Accommodability, and then they'll give you your double time. All right, well, what that means is I had to change the grading. I apologize for how long this takes, but this is important. And instead of having 4 tests, the higher of the 3 plus test 5 plus the final lab total, I've changed it. One part of your grade will be the sum of the 4 highest tests plus test 1, or the sum of all 6 quizzes. Test 5 will be 100 points. The final exam are 5.4% of your grade. I forgot how many points they are. And the lab is still the same points, but the percentage has gone up. So what does this all mean? And this is in the syllabus. Your student percentage to get your grade is calculated by the following. X is the sum of the 6 quizzes total points, not test 1. Y is the sum of the 4 highest quizzes plus test 1. Z is equal to the higher of X or Y. Whichever is higher, X or Y, I'll use the Z. And your percentages, your points from Z plus test 5 points plus the final exam score plus the lab total plus the extra credit points, and I'll talk about that later in the semester, times 100 divided by 560. That will give you a percentage. This hasn't changed. The grade cutoff, 90 or above, A, 80, 89, B, 70, 79, C, 60, 69, D, less than 60, or F. And that's the major changes I've made. Everything else stays the same, other than from the tentative outline, I've taken out where the other tests used to be. I have not put in the quizzes because I'm not sure the final dates, but the test 1 and test 2 will be the same. Test 2, like I had before, will be comprehensive. I'll talk about that in November when I go through the review. Wow, that's a lot to talk about. Now, one other thing I haven't had a chance to change them. In the lecture folder of Blackboard, I have test 1 review. Since test 1 is essentially, or quiz 1 and 2 are test 1 and 2 together, or that. Let me repeat. All right, reboot. All right, quiz 1 and 2 are essentially test 1, split up. Therefore, the review for test 1 will be the review for quizzes 1 and 2, as I have described in the announcement what areas are covered. Since I went through all that on the 7th of this month, I'm not going to do it again today, do a review for quiz 1 and 2. Now, I'll have time before quiz 3, 4, 5, and 6 to change the review, so you'll actually see a quiz 3 review, 4, 5, 6. And I just want to make that. Again, let's take a quick look. All right, everybody see my YouTube channel? Thumbs up, people. Thank you, Brianna. All right, if you go back to the Zoom meeting, hi there, Dr. But anyways, well, who's that handsome guy? But anyway, I said it was Awful Humor Monday. You look at the file 2022-09-07. I did the review for test 1. And if you look at the information, it says test 1 review. I would go back and look at that, and that will help you for quiz 1 and quiz 2. Any questions? I hope I didn't confuse anybody. Hope I didn't confuse me. All right, with that, don't forget, tomorrow I'll send out the email for quiz 1, and you'll have until Wednesday to hand it in as an upload. Now, one final note. Since I've been doing this since the pandemic hit for this class and other classes, both at College of DuPage and Elgin Community College, and because Dr. White's sneaky sometimes, I have developed methods, to find out if a student cheats. And unfortunately, those methods work quite well. Do not cheat on my quizzes. The test will be proctored, so I don't have to, I'm not concerned about that because you'll be taking it, but I will know. Unfortunately, they work. How do I know? Because I've caught students doing that. What's in my syllabus, I will do. All right, let's get back to work. And remember, last time we met, last Wednesday, hope we all had a good time since we last met. I got a lot done. Oh, one other thing. You should be able to see in Blackboard, labs you've handed in from the previous week are graded and the scores are in there. If the score is not in Blackboard for a lab, 1, you never turned it in, or 2, you didn't turn it up, the whole lab in. I've got to email someone today or tomorrow, let them know they didn't put in the actual lab questions, and that's why you didn't get a grade. All right, let's get back, let's get to work. All right, now we're talking about molecular compounds, otherwise known as covalent molecules or compounds. And what's a covalent bond? That's equal sharing of pairs of electrons. I don't know when I started doing this, holding hands like that. It's actually a knuckle coupler, like on a train. You connect atoms together to make molecules. And as I mentioned, and by the way, this is for test number 1 material, not the quizzes this week. All right, getting confusing. But anyways, There are different types, all covalent bonds are dealt with valence electrons. And when we have a covalent bond or molecule, we have bonded electrons. Those are the pairs of valence electrons that are shared between atoms in a covalent bond. And we have non-bonding electrons. Those are pairs of valence electrons that are not involved in a sharing. In other words, a chemical bond. Now, how do you do this? Remember the octet. All molecules want to have, or not molecules, all atoms except for hydrogen want to have surrounding either their own or shared 8 valence electrons, which is why it's called octet. And we did some of these last week, but let's go through and do ammonia. And here we have ammonia. And how do you proceed? Well, first of all, you wait until Dr. White opens up a periodic table. Oh, come on. And by the way, if your periodic table, if you're looking online, Control-Shift+ will rotate it 90 degrees. All right, everybody see my periodic table or your periodic table? Thank you, Anna. All right, so we're doing ammonia. We need to know how many valence electrons hydrogen has. You look at the top of the column and you see the number 1. Then for nitrogen, chemical symbol N, how many valence electrons does nitrogen have? And you look at the top and you see the number 5. So nitrogen, 5 valence electrons, hydrogen, 1. So we now know that nitrogen has 5 valence electrons, hydrogen, 1 valence electron. Now, if I do the Lewis structure, and when you're doing the problem, you don't have to do all this, but I'll show you the final answer. Now, hydrogen is the only exception of the octet rule. Its octet is 2. So the nitrogen, and remember there are 3 hydrogens, the nitrogen has 1, 2, 3 single unpaired valence electrons. And it looks at hydrogen and the nitrogen says, oh, I've got a valence electron here. Hydrogen atom, you do, let's share. And we form a chemical bond. There's 2 more, and we have 2 more hydrogens because there are 3 in ammonia, NH3, and the second one does the same thing. And finally, the third one, third hydrogen, says to nitrogen, oh, you still have 1 unpaired electron? I have 1. Let's share. And they do. And here is your answer. Now let's take a look at this. All atoms want to have octet except for hydrogen. So if we look here in red around nitrogen, how many valence electrons do you see? Well, there's 2, 4, 6, 8. It has its octet. Now, if we look at any hydrogen in blue, I like Dr. White going multicolor on you. But anyways, how many valence electrons, shared or alone, does hydrogen have? And that one has 2. And if we look at the other ones, they have 2. So this is now a stable molecule. Everybody's happy because they either have their octet of 8 or hydrogen has its octet of 2. And that's how you do it. Now, just for reference, these are the non-bonding electrons. And these are the bonded electrons, and you should know that. And that's how you do molecules, covalent molecules with the Lewis structure. Well, actually, we're not done yet. All right, now, turns out Mother Nature, who's the greatest of all chemists, is quite creative. And there are different types of covalent chemical bonds. And it's time for Dr. White to be subtle. And you should know this. There are 3 types of covalent bonds. The first one is a single bond. And a single bond, you should know, is a bond between 2 atoms share 1 pair of electrons. Single bond sharing one pair of electrons. So this is a single bond, a bond between 2 atoms that share 1 pair of electrons. Remember, pair means 2. Now, there's also a double bond. And a double bond is a bond in which 2 atoms share 2 pair of electrons. Double bond is a bond in which atoms share 2 pair of electrons. Boy, this bonding is thirsty work. All right, so single bond, sharing a 1 pair of electron between 2 atoms. Double bond, sharing 2 atoms, between 2 atoms, 2 pairs of electrons. Let me say that again. Double bond, sharing 2 pair of electrons. And finally, triple bond. Triple bond is a bond in which 2 atoms share 3 pairs of electrons. So a triple bond, you have 2 atoms sharing 3 pairs of electrons. Now, if we're in a classroom right now, we do the following, and hold on. Even though I have a slide for this, I'd write the following on the board. And you'd be waiting patiently while I'm doing this on the board. So please be patient. Wednesdays, I'll learn to draw straight lines on a tablet. But anyways, not as neat as a Word document table, but it gets the job done. All right, everybody, together with me. And if you're at home, you don't have to turn on your microphone, but say it out loud. If you're watching on YouTube, say it out loud. What's the first type of covalent bond? Single bond. What's the second type of covalent bond? Double bond. What's the third type of covalent bond? Triple bond. And a single bond has one pair of electrons shared, double bond, 2 pair, triple bond, 3 pair. You should know this. Let me not cheat you out of this. Everybody get the message? Subtle. Know this. All right. If we're in a classroom right now, I'd say, oh, come on, everybody together with me with feeling. What's the first type of covalent bond? Everyone, single bond. What's the second one? Come on, with feeling. Double bond. And what's the third type of covalent bond? Triple bond. Remember, a single bond, 1 pair of electrons, double bond, 2 pair, triple bond, 3 pair. And you should know this. Hint, even says it on the screen. So what does this mean? Well, it means there's certain types of bonds that you can show with a Lewis structure. And let's look at something that you're all using right now, at least I hope you are. As you inhale, the air around you contains 80% by weight nitrogen gas, N2. All right, so as soon as you see, and by the way, if you can't read, it says 3 points each, draw the Lewis structure 4. Remember, this is material on test 1 coming up in, I think, October. I have it. We got a while before it is. Not that long, couple weeks. But anyways, we have 2 nitrogen. You have to find, as soon as you see Lewis structure, valence electrons. Nitrogen, how do you find that? You go to your favorite, your friendly neighborhood periodic table, as you see on the screen. Look at the top, the number above in red or black. If you can't read Roman numerals, V is 5, is 5. So nitrogen has 5 valence electrons. Now, if I take my nitrogens, and I've got 2 of them, and notice each nitrogen has 3 single valence electrons. Remember, when you're doing Lewis structures of elements, and listen carefully, this is for only elements, you put 1 dot on each side before doubling up. It's different for molecules. So this nitrogen says to this one, I've got 1, 2, 3 unpaired electrons. You've got 1, 2, 3 unpaired electrons. Let's share. And they do. So the non-bonding electrons on top come along for the ride. How many pairs of electrons will we have between them? Well, each one has 1, 2, 3 single electrons, valence electrons. And I'll put them each one between that. So how many pairs of dots between the two nitrogens? 3 pairs. Remember, pair means 2. And the question is, what kind of bond, covalent bond, is in nitrogen gas? Well, 3 pairs of bonded electrons. Oh, look, that's a triple bond. 3 pair of electrons, triple bond. So the nitrogen you're breathing, N2, has a triple bond. And you wonder, why am I learning this stuff? Well, guess what? What's going into your lungs right now, 80% of it is a molecule with a triple bond. While we're talking about air, let's do another one. The 20%, which is quite important, 20%, is oxygen gas, O2. And the same question would be, draw the Lewis structure for oxygen gas. Well, as soon as you see the Lewis structure, you know you're dealing with valence electrons. So we have 2 oxygens, O2, and now we have to find how many valence electrons oxygen has. I'll give you 10 seconds to figure that out on your own, then I'll tell you. Ready, set, go. I'm watching the clock up here. 3, 2, 1. Time's up. If you know, or you should know, the chemical symbol for oxygen is O. Valence electrons are listed on top of the column by the number, in this case, 6. So oxygen has 6 valence electrons. Now, do you have to write this down? No, but I have found the more you let the test paper do your thinking, the better your score is. So if I were taking this test, I would. So I'm going to draw the Lewis structure for each of the 2 oxygen atoms. And here they are. Remember, for elements, you draw 1 dot on each side before doubling up. And this oxygen has 1, 2 single electrons, unpaired electrons. This oxygen has 1, 2 single valence electrons. And this oxygen says to that one, I've got 2 single electrons, you have 2 single electrons, let's share. And they do. This has 2 single electrons, this has 2. Now, the non-bonding electrons here come along for the ride. So don't forget that. And I just remembered something I forgot to for nitrogen. But let's finish up oxygen, then we'll go back to nitrogen. What kind of covalent bond exists in the molecule oxygen gas? Well, if you look between the 2 atoms, how many pairs of electrons? Remember, pairs 2. and that's 2 pairs of electrons. Remember, those are valence electrons. And if we go back to our friendly neighborhood chart up here, 2 pair electrons, that's a double bond. And that's something you should know how to do. Now, in oxygen, when you're inhaling oxygen from the air, you're inhaling a molecule O2 that has a double bond. And you're also inhaling a molecule, nitrogen gas, that has a triple bond. Why are you learning about these bonds? Because it helps keep you alive. If that's not a good reason, I don't know a better one. All right, now what I forgot to do for nitrogen, I'll do here, and I'll go back and do for oxygen first, then nitrogen. When you form a molecule, chemical bonds, molecules, atoms in that molecule want to have 8 valence electrons. The exception is hydrogen, which is 2. So if we look at this oxygen, bonded and non-bonding electrons, how many electrons do you see? 2, 4, 6, 8. If we look at the other oxygen, how many shared and non-shared pairs of electrons or electrons total do we see? 2, 4, 6, 8. So in oxygen gas with the double bond, you see 8 valence electrons for each atom element. Remember, hydrogen is an exception. Now, if we look at nitrogen gas here, same thing. If I look at this, on this nitrogen atom, how many shared and non-bonding electrons are there? 2, 4, 6, 8. Octet rule, it's happy. If I look at this nitrogen, how many shared and non-shared pairs of valence electrons are there? 2, 4, 6, 8. 8 valence electrons. So it's happy. Isn't it nice to have happy atoms in a happy molecule? Of course. Oh, that was hokey. Now, let's look at the next molecule, hydrogen cyanide, HCN, which is a very dangerous poison. Let me just close something. All right, everybody see my whiteboard on the screen? Thumbs up, people. Do you see my whiteboard with the double bond oxygen? Thank you, Anna. Thank you, Brianna. All right. Same question. Draw the Lewis structure for hydrogen cyanide. We have 1 hydrogen, 1 carbon, 1 nitrogen. Now we haven't. We've already looked up hydrogen has 1 valence electron. We've already done nitrogen, 5 valence electron. Now carbon, how many valence electrons? Well, if we go to our friendly neighborhood periodic table, I'll give you 5 seconds to look up how many valence electrons carbon has. Your turn, go. All right, carbon, chemical symbol C. Look at the top of the periodic table column, and you see the number 4. Carbon has 4 valence electrons. Now, hydrogen has 1, carbon has 4, and nitrogen has 5. Now, the only way to make this work is to have carbon in the center. Hydrogen has 1 single electron, carbon has 4 single electrons. So the hydrogen says to carbon, hey, I don't know if they say, hey, but how would you like to share an electron with me? And each one brings 1 to the table. So now this is spoken for. Carbon has left over 1, 2, 3 single valence electron. Nitrogen has 1, 2, 3 single electrons. Carbon says, I have these 3 single valence electrons. Nitrogen, you have 3, let's share. And they do. Now, the non-bonding electrons on nitrogen on top there come along for the ride. And this is the structure of hydrogen cyanide. And I would ask you, what type of bonds are in hydrogen cyanide? And I could say covalent bond. And if we look here, between the hydrogen and carbon, how many pairs of electrons are there? 1 pair. And 1 pair of electron is a single bond. And between the carbon and nitrogen, there are 3 pairs. And what kind of covalent bond is 3 pairs of electrons being shared? Triple bond. So in HCN, hydrogen cyanide, you have a single bond and a triple bond. And that's how you do it. Any questions so far? So let's review real quick once again. You should know what are the types of covalent bonds and how many pairs of electrons are there. A single bond has 1 pair of electron, double bond, 2 pair, and triple bond, 3 pair, 3. And remember, a pair means 2. So in a single bond, there's 2 electrons, double bond, 4, triple bond, 6. 1 times 2, 2, 2 times 2, 4, 3 times 2, 6. With that, it's time to take a break. I'll see you in 5 minutes at 9:55, and we'll continue on. That's better. We're back. I'm back. Hopefully you're back. All right. Let's continue on where we left off. That's weird. Hang in there one sec. That's better. All right. Thumbs up, people. I had to close some extra windows. Zoom was getting confused. All right, everybody see on their screen CO2? Uh-oh. Let's try this again. All right, everybody, do you see on your screen CO2 in blue? Thank you, Anna. All right, let's do one more and let's have you try this. See, I'm going to share the fun. So the question is, draw the Lewis structure for now, CO2 is carbon dioxide. And if you look at POP, Dr. White's from the Chicagoland area. That's where I was born and raised. And the stuff you buy in a can or a bottle that's carbonated and non-alcoholic, I call POP, not soda. So does everybody else who grew up in this area. The little bubbles are carbon dioxide. And if you look at a glass of beer, champagne, or sparkling wine, the bubbles you see in there are carbon dioxide. And when you burp, the good part of your burp is CO2, carbon dioxide. That's one way of your body getting rid of carbon waste and oxygen. All right, draw the Lewis structure for CO2. Now, I'll help you out. We've already looked at this. Carbon has 4 valence electrons. Oxygen has 6 valence electrons. The only way this will work is with carbon in the center. So it's your turn to try this out. Remember the octet rule. Remember 3 types of covalent bonds: single, double, triple. And when you're done, give me a thumbs up. Thank you, Brianna. Please be patient. I give everybody time to finish. So all of you out in YouTube land, don't forget, finish. I haven't said this in a while. Don't forget, there's no such thing as a dumb question in my class or in my universe. And if you have any questions, email me or come to my office hours. All right, let's get going. How many valence electrons does oxygen have? Well, you figure that out, 6. How many does carbon have? 4. And I'll do the other oxygen. Now, this oxygen says to carbon, I have 1, 2 non-paired valence electrons. You have 1, 2. Let's share. Carbon has 2, oxygen has 2, and the non-bonding electrons, top and bottom pair, come along for the ride. This oxygen says, carbon, you still have 2 single valence electrons. I have 2 single valence electrons. Let's share. And they do. This has 2. This has 2. And the non-bonding electrons, these pairs, come along for the ride. And the next question I would ask you is, if this is the Lewis structure of CO2, what type of bond is between carbon and oxygen? Well, how many pairs of electrons? 2 pairs. And in case you forgot, or you haven't learned it yet, the 3 types of covalent bonds, single, 1 pair, double, 2 pair, triple, 3 pair of electrons being shared. In CO2, carbon dioxide, there's 2 pair of electrons being shared between each oxygen to carbon, and that's a double bond.
I have a question.
I do questions.
Okay, so I just want to make sure. So when we have like some single electrons, every time we have to combine them, right? So
Right.
we have
You're
like
not going to find a molecule with a single electron in a covalent bond.
okay. So
Or
every
in a
time we have
molecule. I can't, you're never going to find in the chemistry we do in this class, you're never going to find an element in a molecule that has a single valence, unpaired valence electron. Never.
okay.
And I don't know if I told you this, I'll bet money on it. Whenever I say I'll bet, I already know I won. So never bet with Dr. White. Because I won't bet unless I know I've already won. So that's how you do it. So the next time you see a friend burp, or if they're drinking some pop, you can say with the pop, you know, the bubbles in the pop is carbon dioxide, and there are 2 double bonds in that molecule. Don't. Friends don't want to hear about double bonds when they're drinking pop. All right, let's continue. Now, the next couple of slides are the way they are in your book. And I'm going to just run through this real quick because we've already covered all this. Valence electrons, the number of covalent bonds, need at least 1 vacancy on an atom shell to be able to form a single bond. In other words, it's got 1 or 2 or 3 unpaired electrons. Need at least 2 vacancies for a double bond and 3 for a triple bond. When we talk about vacancies, it's to get to get the pairs of electrons. Another way of thinking of this is carbon, since it has 4 single valence electrons, can form 4 single bonds or double bond and triple bond with single bonds. Nitrogen with 3 can do single, double, or triple. Now, oxygen only has two vacancies, meaning two unpaired electrons, and it can only form single and double bonds. But you can figure that out on your own, just like I showed you. And there are some exceptions to the octet rule, but I'm not going to cover that in this class. And we've shown this for Lewis structures. Now, let's continue on and talk about polyionic compounds present in a molecule. It turns out, and many of the molecules in our daily life have both ionic and covalent bonds. Again, many of the molecules have both ionic and covalent bonds. I won't cover it in this class, but the next time you clean your hands with soap, hopefully you wash your hands at least once a day or more, hopefully more, the soap you're using, whether it's a liquid out of the pump or the bar, the actual molecule that cleans the dirt off your hands, notice Dr. White washed his hands this morning, or when you take a bath or a shower, the soap you're using has both ionic and covalent bonds. One of the things you should get used to is anything you look at, the plastic, the water, my hair, my skin, they're all made up of atoms held together by chemical bonds. And they can, hand sanitizer too. It has molecules that have, well, hand sanitizer, it matters which one you're using. I think most of them have either isopropyl alcohol or ethanol, and that has all covalent bonds. But the soap, and I don't teach it in here, but if you're taking my organic chemistry 1212 here, Chem 170 at Elgin Community College, I teach about soap and also how it works, but that's organic chemistry, different class. Oh, you just have to come and take it. One thing about hand sanitizer, be careful. The chemical that does the sanitizing, which is usually ethanol, is very flammable. Look at the label. The label of hand sanitizer should tell you, warn you, it's flammable, and it is. Long before the pandemic, when the bank of mine, I saw they had this huge bottle for the tellers, not for the customers. It was before the pandemic. Now they have it for the customers too. I said, oh, you're using that? And they said, yeah. And I said, you know, that's really flammable. Be careful. Don't smoke around her. Really? I said, bring the bottle over here. And she did. I said, see on the back, it says down here, flammable. And she thanked me and showed all the other tellers, which I was glad I did my civic duty as an organic chemist or chemist. Now, you can have compounds that have both ionic and covalent bonds. So in a polyatomic ion, you have both ionic and covalent bonds. And let's look at the following KOH. And the same question would be, draw the Lewis structure for KOH, which is potassium hydroxide. Well, if we're going to do a Lewis structure of that molecule, we better find out valence electrons. So I'll now go to my periodic table, and I need potassium, K. And I look at the top, it has one valence electron. Hydrogen in KOH has one valence electron, and oxygen, O, look at the top, has 6 valence electrons. All right. And let me do this so you don't think that's the letter I. But now I have to teach you something very important. And that is for this class, and this will always be true, except for hydrogen, which is not, all alkali metals always form ionic bonds. All alkali metals, and for this class, that's lithium, sodium, potassium, always form ionic bonds. The same thing for magnesium and calcium. They always form ionic bonds. I don't know one exception to what I just told you. And for a number of years now, I've asked other chemists, do you know of an exception? And the answer has always been no. So whenever you see an element in the periodic table, or an element that's an alkali metal or alkaline earth metal, lithium, sodium, potassium, or magnesium or calcium, it will never form a covalent bond. It will always form an ionic bond. So the question is, what ion does potassium form? And the nearest noble gas is argon at 18. Potassium has 19. Now, we can figure it out, and we've already done this for sodium. I think I did it for lithium, but it'll also be true with potassium. Lithium, sodium, and potassium always form a +1 ion. So how do we show that? Like this. Now, oxygen has 6 valence electrons. Hydrogen has 1. And the hydrogen atom says to the oxygen, I have 1, you have 1, let's share. And they do. Now the potassium is still K+. Now let's look at this, what we've drawn. Remember the octet rule. All atoms in a molecule, unless they're an ion, and an ion also has an octet, by this case losing 1 electron, it has the same number of valence electrons as argon, which is 8, so you don't show it, you show the charge, but that has an octet. Now, if we look at hydrogen, it has 2 valence electrons. And remember the exception to the octet rule is hydrogen, and that hydrogen only has 2 valence or electrons to get its octet, and it does. Now, if we look at oxygen, it should have 8 valence. Oxygen doesn't have an octet. What happens? Well, remember, potassium had 1 valence electron, and it gave it up to form the cation. And where did that electron go? To here. So actually, there's an extra electron. Instead of 7, it will now have 8. But because it gained an extra electron from potassium, it will have a negative charge. So we have potassium plus OH minus, called hydroxide ion. And now oxygen has its octet. And it's happy. So what kind of bonds are in potassium hydroxide? Between the potassium cation and the hydroxide anion, there's an ionic bond. I can spell it. Once in a while, Dr. White has brain freezes for spelling, and you're seeing one right now. Unfrozen. So there's an ionic bond between this and this. Ionic bonds result from transfer of one or more electrons from one atom or group of atoms to another atom or group of atoms. Now, between the oxygen and hydrogen, there's one pair of electrons being shared, and that's a single bond. It's a covalent single bond. So in potassium hydroxide, KOH, there's two different types of bonds, an ionic bond and a covalent bond. Now let's do one more, and that's sodium cyanide, which is a dangerous chemical, which you can convert into hydrogen cyanide, which is a poison. Do not. Now, how do we do the valence, the Lewis structure? Now, sodium, like potassium, has one valence electron. Carbon, which we've done, oh, wait, I see a question. Now, the exceptions you do differently, and I'm not going to cover that in this class. There's certain things I won't cover, and since this is never going to be on a test or the final, I won't cover those exceptions. Just like when we did the electron configuration, we only stopped at magnesium because there are exceptions when you go farther on, and that's something I didn't want to cover in this class. I'd rather spend more time on mainstream stuff that you will encounter in your daily life. And that's my decision, and hopefully it's a good one. All right, let's get back, draw the Lewis structure for sodium cyanide. Now, carbon has 5 valence electrons, and nitrogen, 4, I got ahead of myself, and nitrogen 5. Now, as soon as you see an alkali metal, it never forms a covalent bond. And I showed you how to do this. I won't go through it again. It always forms a +1 cation. Now, I'm going to let you try and figure out what's the rest of the Lewis structure for sodium cyanide. Your turn to have some fun. I'll give you a big hint. There's a big hint. Thanks, Dr. White. You're welcome. And while you're doing that, I'd like to thank everybody who's making me an international, maybe not that, YouTube star. Remember, right now, you should be finishing up and draw the Lewis structure for sodium cyanide, NaCN. And when you're done, give me a thumbs up I'll give you extra time because this is challenging, especially if you're just learning it like you are right now. While you're doing that, let me check on something for myself. Since we're having a quiz, two quizzes this week, normally tomorrow I would have done chapter 9, part 1 and 2. I'll postpone that till next week. So this week you can focus your attention on doing practice and being ready for quiz 1 and 2. Remember, Tuesday I'll give quiz 1 and Thursday I'll give quiz 2. It's on the assignment area Blackboard. You'll have till the next day to take it and upload your answers as a single PDF file, just like you're doing the labs, but in a different assignment area. But it will be called quiz number 1, not lab. Profound. All right, if you want me to start on this because you're sort of stuck, give me a thumbs up.
Is something like that's gonna be on the test number?
What?
Is something like that's gonna be on the test, like these hard examples, or no?
This will not be on quiz 1 and 2, but something like this will be on test number 1.
Okay.
And as always, thank you for your question. All right, let's get going. So we have carbon, we have 4 valence electrons because we looked at the periodic table. Nitrogen has 5. Now, if you look at nitrogen, it has 1, 2, 3 unpaired electrons. Carbon over here has 1, 2, 3. So the nitrogen says to carbon, but you know elements can talk. They can't, but it sounds good anyways. Sounds good. Ooh, awful humor. I've got 3 unpaired electrons. You do. Let's share. And the non-bonding electrons on nitrogen come along for the ride. Now, sodium has a plus charge. Let's try this again. But if you look at carbon here, it has only 7 valence electrons. That's not right. Should be 8. Where is that last electron? Well, remember, sodium had 1 valence electron, which it gave up to become a cation. And where did that electron go? To carbon. Now, carbon should have 7, now has 8. So this whole thing has a negative charge. Now, what kind of bond between, this is called the cyanide anion. I'll never ask names on a test, but I still will use them so you can learn about them. And what kind of bond exists between sodium plus and the cyanide anion? And that's an ionic bond. What kind of bond exists between the carbon and nitrogen and the cyanide anion? Well, in case you haven't learned it, remember there are 3 types of covalent bond. Ionic, there's only one, and it doesn't have a name as well. It does, it's called an ionic bond. And therefore, there's a single bond, 1 pair of electron, double bond, 2 pair of electron, triple bond, 3 pair of electron. And if we look at between carbon and nitrogen, how many pairs, remember pair means 2, of electrons, 3 pairs. So right here, that I just circle, that's a triple bond. So in sodium cyanide, there's 1 ionic bond and 1 triple bond. Now, just to check, if we look at carbon, how many valence electrons does carbon have? 8. If we look at nitrogen, how many shared and non-shared electrons does it have? 8. So both have its octet, and that's the structure. Let me show you how you'd answer that. And this would be the actual answer, but I'm showing you all this because that's the thought process to get to the final answer. And that's how you do multiple bonds. And it turns out multiple bonds, especially double bonds, and single bond, even triple bonds, play an important role in your life. How many of you heard cis-trans or trans fats are bad for you? And that's because of a double bond. The type is, there are different types of double bonds when you get into organic chemistry, which I won't cover here, but that's a double bond causing, sometimes it's good, sometimes it's not as good for you health-wise. And why that's so, I don't know, I'm not a medical doctor, but I believe in medical science. So, and so do the food companies. If you go out and buy things, you'll see packaging and it will say somewhere on the front or back, 0 trans fats. And that makes it more healthier, not totally, because anything with fat in it, feed too much. As my doctor always tells me, get your triglyceride levels down. You're talking about fats mainly, and oils have double bonds in them. All right, watch closely, click. Next couple of slides I want to cover, but I will not have on test number 1. And there's not much on the ACS, so I'll cover it later on in the review. But molecules are not flat. And this, like I write on a piece of paper, molecules exist in 3 dimensions, just like we do. Am I flat if you were in person with me? No, I have X, Y, and Z. I'm in 3 dimensions. So are you, and so are molecules. And what does that mean? Molecules have shapes. And those shapes play an important part in our life. And these are determined by the number of types of bonds in an atom of a molecule. And like I said, they exist in 3 dimensions. And the shape is determined by the number of valence electrons and the type of covalent bonds. And again, switches off, but there's a theory that has evolved called the VESPER theory. And VESPER is the acronym for valence shell electron pair repulsions. Now, valence shells, electrons, are the outermost shells of an atom element. And we're talking about 2. And repulsion, how many of you ever taken 2 magnets and gone like this? They are bar magnets in the north and north ends. All of a sudden they go, whoop, because they're repulsed. Well, in nature or in our world, things that have charges are repulsed. Opposites are repulsed. So something has a negative charge here, a negative here, and you bring it together, it doesn't want to, it repulses. Same thing with positive. Now, in ionic bonds, opposites attract. And I've heard you, I'm sure you've all heard, I'm out of tea. Not out of water, but opposites attract, and that's why plus and minus form an ionic bond. Well, when you have valence electrons, they want to be the pairs as far away from other valence electrons. And to do that, molecules have different shapes. And the VESPER theory teaches us how to determine those shapes. And the VESPER theory, and again, switches off, click, is a set of procedures for predicting the 3-dimensional shapes of a molecule using the information in the molecule's Lewis structure. And you have 1 pair of VESPER electrons, and that should be a capital R. It's going to be linear. 2 pair, trigonal planar, and 4 pair, there's different possibilities. Tetrahedral, when you have no bonding pairs of electrons. Trigonal planar, 1 pair of bonding, non-bonding electrons, and angular, 2 bonds, 2 non-bonding pair. All right, everybody see VESPER theory from Wikipedia on your screen? Thumbs up, people. Thank you, Brianna. All right, now, if we scroll down, one of the things I should tell you is that Wikipedia for chemistry, I don't know about anything else, but for chemistry and especially organic chemistry, but chemistry in general, has been so heavily policed by people like myself and other PhD chemists that it's been many years since I found any major mistakes in a chemistry entry in Wikipedia. If I do, because of my credentials, I have it changed, and they do change it. But we look at what are we talking about? Different shapes. This is linear, this is called trigonal planar, and this is called tetrahedral. And here is bent, here is trigonal planar. And what that means is you look at the valence electrons and the bonded and non-bonding electrons. If we look at water, here's a picture of bent. We did this already. Well, water, let me make sure you can see it. And you can. Everybody see H2O on your screen? Thank you, Anna. Now, here's the Lewis structure for water. Notice you have two pairs of non-bonding electrons and two pair of bonded electrons. So what's the shape of water? Well, all four pair want to be as far apart as possible. And the way to do that is by bend. And water is not straight. Think of A in here being the oxygen, and X is our hydrogen. So water is not straight across, it's bent. And if we look at methane, CH4, it's got this tetrahedral structure. Again, for ammonia, one pair of non-bonding electrons, Z, and the A is nitrogen, and the three hydrogens, so it's called trigonoplanar or pyramidal. I always say you get that wrong. And molecules have shapes, and those shapes affect everything in our life. The way it bonds the shapes of atoms in a molecule help form, are you ready for this? Our DNA shape and RNA, the double helix. And those things, again, it's very complex, but it's all because atoms form certain shapes to keep the pairs of electrons as far apart. Now, something I just noticed I don't have slides for, bad Dr. White, is the following. Let's look at the following consideration. Hang in there, I'm almost finished.
Is this going to be on the test or quiz?
On the test one, not on the quizzes, okay?
Okay.
Tests have more information. All right, so the question is, what's the empirical formula for the covalent molecule So let's look at A. What's the empirical formula for the covalent molecule with hydrogen and oxygen? Well, how do you do that? Well, first of all, you know, hydrogen has one valence electron and oxygen has 6 valence electrons. Now, oxygen wants to get to an octet. So how many more valence electrons does oxygen need to get to 8? And if hydrogen's the only one providing valence electrons, you need 2 more. So you need 2 hydrogens and 1 oxygen. I'll put a dash there so you know it's not the letter number 10. How do we show that? Like this. And that would be the molecule. And that's why water is H2O. It's not H6O7 or 18 or whatever. That's the simplest formula that's formed in order to give oxygen its octet. Remember, hydrogen's octet is 2. And that's how you do it. Let's try another one.
So we need total 8 or 10?
What?
We need total 8 or 10
8.
for the
It's always 8. The
Always
exception
8.
is hydrogen. Here, let's look at the actual, and this you don't have to do. But see, when you look at the valence electrons, each hydrogen has its octet of 2. And the oxygen has 8. But this would be the correct answer. And I could put nitrogen and hydrogen. So we do the same thing. We say, how many valence electrons does nitrogen have? Well, you look at the periodic table. We've done this already, so that's why I'm not going there. And you see it has 5 valence electrons. And hydrogen still has 1 valence electron. So how many valence electrons does nitrogen want to have to be happy? And the answer is 8, but it only has 5. And if it needs 8, and each hydrogen can only give 1, how many more does it need? 8 minus 5 equals 3. And if each hydrogen can only give 1, and it needs 3, you'll need 3 of these. So what's the empirical formula for a molecule with nitrogen and hydrogen? 1 nitrogen and 3 hydrogens. And now everybody's going to be happy. Speaking about happy, we're just about done today. Now, something I should have mentioned earlier, but I'll mention now. The lab we'll do tomorrow, the density lab, has some very interesting graphing you're going to have to do in Excel. And by the way, if you don't have Excel, you can download it free. College of DuPage students have free access to, I think it's called Microsoft 365. It's a version of Microsoft Office. And because you have to not only graph it, but determine the equation for a line to get a number for the lab answers tomorrow, I will go through that in our meeting that will be on the videotape for those of you watching the videotape. Hello, all you YouTube people. But anyways, that I'll do tomorrow. And with that, I'm going to end a whole 35 seconds early. Actually, I don't have to do these Zoom meetings. I just have to meet with you like in my office hour twice a week for this net course. But that's not good for to help you learn, which is why I do these Zoom meetings. And with that, I'm done for today. I'll see you tomorrow. Don't forget, hand in the lab that's due tomorrow. Anna, when you say one example, what do you mean?
Just the example that you did. I just have a question because I don't know if I understand it.
I'll do that tomorrow, okay?
Okay, got it.
Ask me the beginning of tomorrow before we do the lab, and I will do it because I always answer all questions the best I can. With that, I'm done for today, and I'll say, Gang gesund. Remember, that's Yiddish for go in health. Gang gesund. Goodbye now. I stole that from Granny at Beverly Hillbillies. Bye.